So now we're going to talk about yet another type of operator in fluxes called suppressing operators. And these operators create a flux or other things that, like a mono, that can change or ignore portions of the payload. Now, we've talked about some other examples of these earlier and in other contexts, but now we're going to talk about it in the context of fluxes. So the first one we're going to talk about is the filter operator. And this should look very familiar because it's very much like what we've got in Java streams. What you do is you take each item flowing through the flux stream and you apply a predicate to it, and only things that pass the predicate are allowed to continue on. But if something does not pass the predicate, then the value is just ignored and we go on to the next thing. What it returns, of course, is a new flux that contains only the values that pass the predicate test. So here's the little metaphor to think about when you think of filter. It's like some kind of flower filter where you want to get rid of any things that are too big or have impurities in them or something, so on and so forth. So that's the basic idea. One thing to remember with filter is that the number of output elements from filter may be less than the number of input elements. And so in this particular example, which we'll take a look at later, we're going to generate a bunch of random integers from 1 to s max iterations, but we're only going to let ones through that are odd because we're going to be checking for primality. So there's no point in checking for primality of an even number because we know it couldn't possibly be prime. So we filter it out. Note again that filters behavior, its predicate, can't change the results. They can only fail to emit them if they don't pass the predicate. The type or the value can't be changed. RxJava has something identical. They have a filter operation that works in exactly the same way for exactly the same purpose. And Java Streams has a filter operation that you know and love that also works the same way. This is how you only emit odd numbers in Java Streams. Same basic idea. Should probably change that to toList instead of collect to list. Trying to get better about that. Let's talk about another operator that also has a familiar equivalent in Java Streams that we've discussed before, and that's the take operator in Flux. And as the name suggests, it takes only the first n values if they're available. Of course, if there aren't n values at all, it'll stop whenever the stream is finished. But if there are more than n values, it'll stop after n of them are taken. And the parameter that's passed is kind of obvious. It's the number of things to take from the stream, and it returns a flux that is limited to size n. So it's kind of I should put a picture of Procrustes here. Does anybody know who Procrustes was? Procrustes was a famous Greek mythology figure. If you ever read any of the Percy Jackson books when you were a kid, there was Procrustes was one of the characters, and he was an innkeeper who offered you a deal. If you came to his inn, he would give you free food and lodging for the night. But there was a catch, and the catch was he would put you in his bed, and if you were too short, he would stretch you, and if you were too long, he would chop you up till you fit. And that's what's often called a Procrustean bed. So trying to fit something that doesn't really fit into a form factor that doesn't really work is called a Procrustean bed. So you can think of take as somewhat of a Procrustean bed. It'll chop you off if you go too far. I like that. I'm going to put that in there. So here's an example of how we can use this to limit otherwise infinite streams. You can have something that generates values every so often, every half a second or whatnot. And we don't want it to go on forever, so we're going to stop after max iterations of these things have been emitted. So interval and take often work together nicely like peanut butter and jelly. There's a similar method, identically named method with exactly the same semantics in RxJava. And of course, in Java Streams, there's a limit method that works pretty much like take does. So here's an example where we're only going to emit the first 100 odd numbers in a stream. And we do that by using the iterate factor method that will go on forever, generating values starting at 1 and adding a value to that, but we stop after 100. The next operator we're going to talk about is a very interesting operator. And at first glance, you're like, what the heck is this operator doing and why do we need it? Well, it turns out to be incredibly useful, but it's not clear at first. So this is called the then operator. And this allows the flux to complete, and then it'll play back a signal from the provided mono. What the heck? So you give it a mono parameter that emits after termination. And so what you typically do here is you tell it to ignore elements from this flux So whatever this flux was doing, ignore them, whatever it's emitting, and instead emit the result that comes out of this provided mono. And it returns a new flux that waits for whatever it's doing to finish and then emits the value from the supplied mono that's passed as a parameter. Well, what the heck is that useful for? And it took me a while to figure this out until I started trying to write my code that would wait for a bunch of asynchronous operations to complete in the background and then and only then return from the caller thread. And this turns out to be very useful in that context. So here's an example of something that's going to be running in the background. And what we're going to do is when all these background computations complete, then we're going to go ahead and display results. And this is also going to return an empty mono that is going to trigger the async task bearer to say, we're done, you can now go on and wait for other things to complete. But if I'm the last one to finish, I'm out of here, or you should be out of here. Very subtle. There is no particular equivalent in RxJava, although they have this thing called a completable that can be used in a similar way. Since we're not really talking about RxJava, however, not too much to worry about. If you ever do RxJava, though, and you want something like this, you can use this via an observable ignore elements method, which basically says, whatever's been going on up to this time, when it's finished, ignore anything else that came from it, and just return a completable that says, I'm done. This is a little much like the Java completable future then run operation, where you can just say, do this thing, and then be done with you. Go away. So that's the end of the discussions of suppressing operators in the Flux class. And you'll see that these, especially the one that's the take and filter, get used all over the place. Many, many examples of using take and filter. There are some other suppressing operators, but these are the ones that we're going to focus on because they're the most relevant for the examples we're going to look at.